Hello and welcome to this video about forces, and in fact it's resultant forces that we're going to be talking about. And to help us understand this, we're going to look at different forces on a box, and we're going to look at what happens to the movement of that box based on the forces that are acting on it. So if we start off nice and simply with a force that's going in this direction to the right of the box, and let's say the force is 10 newtons. It's quite easy to understand that this box would move towards the right hand side if we added a force of 10 newtons towards the right. In actual fact, we say it would accelerate towards the right hand side. The overall force, or the resultant force, is 10 newtons towards the right hand side. Now that's quite simple to understand, but let's start again and add a different force. Or what actually means add two forces. So let's say that on this side we have 10 newtons to the right, and on this side we have 10 newtons to the left. If the object started off as being stationary, and by stationary we mean standing still, and we added two forces to the left and to the right, and each one was 10 newtons, you could probably imagine that each of these forces balances each other out, and so we say the resultant force, in other words the overall force, is 0. So the object would still not move. So 10 newtons in this direction, 10 newtons in that direction, resultant force of 0. So that's quite easy to understand as well. What we could do is start off with our stationary object, but instead of having two equal forces, let's try and roughly double the size of that line. And let's say that on this side we have 20 newtons of force, and on this side we have 10 newtons of force. Well, in this case you can see that there's more force towards the right, and in fact if you do the maths you could work out that it's actually 10 newtons of force towards the right. So in other words, we would say the resultant force equals 10 newtons towards the right, and from previously you could say that the object starts to move, or move towards the right, or it accelerates towards the right. We can actually take off these arrows and simplify it to one single arrow on one diagram. So we could say that having these two arrows acting on this box is actually exactly the same as having one force towards the right of 10 newtons. And that is absolutely correct. You can actually simplify the diagram by just summarizing it into one force towards the right, and again we would say the resultant force is 10 newtons, and this box would then accelerate towards the right hand side. We can look at a slightly different scenario. In this case we've got two forces acting towards the right and one towards the left, and let's just say, I don't know, this is 5 newtons, this is 10 newtons, and this looks like something like, I don't know, maybe 7 newtons. In the same way you can say, well, over towards the right hand side you can add these two forces together, so the 10 plus the 5 would give you 15 newtons of force towards the right, and we have one force on the left which is 7 newtons. So overall this object would move towards the right, and the overall force would be 8 newtons towards the right. So the resultant force equals 8 newtons. And again we can simplify this into one diagram, and we can say that the overall force is actually 8 newtons towards the right. So this diagram is a simplified version of this one, where we've just taken the resultant force to show what happens, and you can absolutely do that with forces acting in opposite directions. Remember, these objects were stationary to start with, they were not moving. But what happens if we've got an object that's moving and we change the forces on it? To start off with, this car is not moving at all. There's no force towards the left and no force towards the right, and it's starting off as stationary, so it's not moving. Imagine we switch on the engine, start accelerating, and we have two forces acting like so. The two forces are the one to the right, which is caused by the engine, and the one to the left, which is caused by friction. Friction caused by the tyres and by air resistance. Now you can see for this car, just like in our box, the force towards the right is bigger than the force towards the left, so this car is now accelerating towards the right. A little while later, what tends to happen as the car gets faster is that the friction forces become bigger. So air resistance and the friction on the tyres becomes, together they become bigger. Let's just remind ourselves those two are the same. They become bigger and we've got a bigger force acting in the opposite direction. But you can probably see that the forward force is still slightly larger, so the car is still accelerating. Eventually, you'll see that once the car reaches a certain speed, the forward force and the backward force are exactly the same. So the air resistance is the same as the force created by the engine to move it forward. We say the resultant force is zero, and what actually happens is the car is then moving at a steady speed. And that's quite important to realise. Remember, this car, while it might look like it's got two forces that are equal and opposite to each other, and therefore it looks like it should not be moving, it actually is moving at a steady speed. And that brings us on to a very important set of rules. If the resultant force on a stationary object, in other words, an object that's not moving to start off with, is zero, so these two forces are balanced, the resultant force is zero, then this object will not move. Will not move. If the resultant force on a stationary object is not zero, in other words, we've got one force bigger than the other, then this object will accelerate. If you look at the forces on a moving object, so we've got the resultant forces on a moving object, if they are zero, then it's very important to remember that this will be moving at a steady speed. Students often get confused by this. They see a car that's supposed to be moving along, they see balance forces, and without thinking they'll say that the car is actually stationary and not moving. But if the object is already moving and the forces become balanced, it will move at a steady speed. If the resultant forces on a moving object is not zero, if the resultant force is not zero, then the car or the object will accelerate in the direction of the resultant force, and in this case it will accelerate towards the right. So it's very important to make sure you understand these two sets of information. We've got the resultant force on a stationary object and on a moving object. It's probably worth just going back over that just to make sure you understand it. If you feel you have understood it, or you've gone over it again and now you feel like you've understood it, let's have a little practice on these diagrams here. Let's start off with our boxes again, and these are both stationary to start off with. We've got two forces acting towards the right and one towards the left. Maybe have a look through these diagrams, just pause for a moment and see if you can work out what the resultant forces on each of these will be. So we have, for the first one over here, 5 and 7, we've got 12 newtons to the right and 10 to the left, so the resultant force is 2 newtons. This object would start to accelerate towards the right. For this one over here, we've got 70 towards the right and 70 towards the left, so the resultant equals 0 newtons, so this object would not start to move. Here is an object or a car that's already moving. We've got 23,000 newtons towards the, it's not 23,000, 2,300 newtons towards the right, and we've got the friction on the tyres, which is 400 newtons, and we've got air resistance, which is 1,800 newtons, so in total that makes 2,200. So the resultant force for this car will be 100 newtons towards the right, and it would be accelerating. And for this car, you can see 2,300 on this side, 2,300 on this side, and if we add the two forces on that side, that's 2,300. That would be going at a steady speed. Let me just tidy up this a little bit. So these are the tidied up answers for these 4 examples, and if you got those, well done, and if you didn't, it might be worth just going back and having a look at the last few minutes of this video again.